Okay, so in this video, I'll be going for the triangular law with vectors, and I'll be doing some particle questions. Alright, so first thing I want you all to get is that with the triangle law, it basically says that the sum of two vectors is equal to another vector, and the name of this vector is called a resultant. Alright, so if you start here and you walk up this way and you walk down this way, so the sum, they went from A to B and from B to C. So the sum from A to B and B to C would just equal to A to C. And A to C is something called a resultant, right? So that's really what you're trying to do with these questions. Alright, so I'm gonna show you the trick. So the trick is I just call it the chain rule, but it has something else with that, but it's just the chain rule. Why I name it the chain rule is that you could think of any sequence of the vectors as a chain. One path links another path. So let's draw a triangle. So if you notice, if we start at A, then we go to B, and we go to C. We could write the sum of these two as AB, because AB is a vector. It has a direction and a magnitude. And then from B to C, we could say BC. So therefore, we could write our equation AB plus BC. Remember, that is equal to the resultant. So in this case, the resultant is A to C. So how I want you all to remember it is that the insides, the letters on the inside, must always be the same. That is the thing I linking them together as you link. As you link, it must be the same. I want to go across to the next thing, it must be the same letter, okay? And the cool thing is, the outside letters in each one will give you a resultant or piece of it. So from the first one, this was A, look A here. And for this one, look C here. When you put the outsides together, it will give you your resultant. Alright, that is literally all it is. Alright, that is the quick and easy way to remember it. So if we go up to these examples here, we could try the same thing. So we have OA. So if we want to go to something else, that means the other thing has to have a beginning. Alright, so if you notice OA, AB, so you see in the link. And if we didn't know what the resultant was, you could just look at these two and be like, okay, so the first one O, and then B, so the resultant will be OB, and we are correct. Yeah, let's try the next one. So we start with AB now. So if you start with AB, the other term has to start with B. So we had BC. And if we didn't know what the resultant was, we just look at the outsides. So the outside will be C and A, so you'll get AC, which is correct. And the last one, we start with OA. So we know the next term has to be plus A something, and that's correct. So the link A and the resultant will be OC, which is what we have here. Okay, so if you also make up something out of the blue that we never saw before, we could still write. So if we had Z, Y. Okay, save as ZY. So I could technically add anything else. I could put say plus YA. Alright, because Y because the link. And what the result will be? It will be Z and A. ZA. Okay, so that's basically what I call the chain rule for the triangle, alright? So the insides must be the same, link it, and the outside will give you a resultant. That is quick and easy way to remember the chain rule. So for example, let's try it. So if I have a triangle XYZ. If I try a triangle XYZ, because that's how your question will come, let's draw the triangle. So we have X, Y, and Z. Okay? So if I wanted to add the two, if I here, I could do my little triangle, so I could start with X to Y, and without looking at the triangle, I could derive the equation. So X to Y, it will have to be plus Y, and I can't put back, so it'll be Z. Yeah? And that will equal to the outsides, which would be XZ. Now let's check and see if this is correct. So X to Y, right? Then Y to Z, okay? And that will equal to X to Z, correct? Alright, so you can actually look at the triangle and see the equation right there. Alright, and that is basically triangular. Sum of 2 has to equal to a resultant. The inside of the 2 must be the same to link it, and the outsides of the 2 will give you a resultant, the other resultant vector, which is basically what you will get when you add both of the vectors together. Alright, so let's try some questions. Alright, so let's try this one. So we have XYZ is our triangle, M is the midpoint. Okay, so they gave us XY and YZ and the one XZ. So express the following vectors in terms of A and B, simplify your answers where possible. Okay, so this is basically the same concept, okay? So we have to look at how we can manipulate what they gave us to obtain our little equation once we obey the laws. So let's see if we can guess. So if we start with XZ, say for example, do we have anything that starts with a Z based on what they gave us? No. Okay, so we know we can't start with XZ. Okay, so we start with YZ. Still, we don't have anything starting with a Z, okay? So you see, you kind of eliminate any ones that you can't use, okay? So the only one that we could use is XY. Why? Because we have XY and we also have YZ. And look the link. And what is equal to? Well, XZ. And what do you look at that? Okay, just to make it clear, what you want don't always have to be on the other side or the resultant. What you want could also be within the equation, like here, and you just had to rearrange the equation to solve it. So let's get the answer for this part. So xy is A, plus and yz is B, and that is xc. Okay, and that is it there. So let's try and see if we can get something with my. Okay, so let's try to sketch a diagram. So we have x, y, and z. So we have xy, that is A, yz is B, the y is your x. Alright, so yz is B, and then we just found x to z, which is A plus B. Okay, so any question that said that the point M is the midpoint of xz. So therefore, halfway through, we have M. Yeah? So if we try and get an equation that has M in it, right, so we can actually manipulate it. So we can start with my. We start with my plus. Let's see what we could plus. Right. Do we have m to z? No. So we could have y to x. No, can't use that. Let's start with something else. So if we start with has m on the outside. So if we have start with xm plus my, that will equal to x, y. Alright, if you look at that. So now, since we know xm, where's x to m? X to m would just be half of a plus b. So that'd be a plus b on 2. Okay, remember xm is just half of xz, right? Plus my, which is what we want, and that is equal to x to y, which is a. So if you rearrange it, you will get my, that's equal to a, and carry this whole thing across, minus a plus b on 2. Alright, and that'll be answer right there. Alright, of course you can simplify it, but you could try it on your own. Alright, so let's try another one. Let's use a different color. Zoom in. Let's see what happened with this one. So what they gave us? They gave us OA, OB, OC, and they want us to get OA. Same thing. So how can I manipulate it? So I could start with OA. Why? Because I know I have AB. And I know I could just add AB to this. And that would equal to the outside, which is OB. So I obtain my equation. Now it's just to solve, right? So just be careful that has vectors in this. So just be careful how you arrange. So now we substitute. So we have 2 minus 2, that is OA, plus AB, which is what we want. And that is equal to OB, which is 6, 1. So rearranging it, AB. So if we will equal to 6, 1, subtract 2 minus 2. So 6 subtract 2 is 4, and 1 minus 2, that'll be 1 plus 2, which is 3. Okay? So nice. So let's try AC. So AC, when we learn, like to start with OA plus AC, and that is equal to OC. And we have everything we need. Alright, so if we plug a 10, where's OA? Or 2 negative 2. Plus AC, and that is equal to OC. Where OC? 10, 4. Alright, so now we just rearrange. So we have 10, 4, subtract 2 minus 2. So 10 subtract 2 is 8. 4 minus 2, that is 4 plus 2, which is 6. Okay, so let's try this one. So collinear, points that are collinear basically means that points that lie on the same line, right? So if I was to draw a line, this will be A, because you have A, B, C. So A, B, and C. So this is if it was on the same line, right? So we're assuming that. They want to know if it is or isn't. So we have A. So the good thing is we have the vectors, the directions. We have AB. Alright, and we also have A to C, which is the whole distance. So if we could show that one is a scalar multiple of the other, alright, so they will be collinear, right? So where's AB? 4, 3. So AB is 4, 3. And what AC was? AC was the whole thing, which is 8, 6. Alright, so you can clearly see that we have AB. So if I multiply AB by 2, so 2AB will equal to 4, 3. That will equal to, if I multiply 2 by 4, I get 8. 2 by 3 is 6. And that's AC. So since A2AB is equal to AC, they are collinear. They lie on the same line because one is a piece of the other one. Okay, and that's the last one. Alright, so that's all. So be safe, guys. Later.